So my name's David Giretta, and I'll be talking about an authenticity prototype at this stage, which Mariella referred to in her overview of the authenticity work that's been carried on in CASPAR. And this is work done in collaboration with my colleague, Matt Dunkley. The previous presentations on authenticity have talked about the reasons why we need a tool, the reasons why authenticity is very important in the context of digital preservation. What we need, what I present here is a tool which allows one to capture a variety of evidence from a number of sources. So it has to be customizable and flexible, because what we do not want to do is to be prescriptive. We know that there are many ways in which people capture authenticity. There are many different types of authenticity. So what I'm presenting here is essentially a framework into which the authenticity protocols, authenticity steps can be plugged, and into which one can insert the various types of evidence that have been talked about in the other presentations. And I'll show some screenshots of the tool. Later in the presentation we'll show the tool at work, and I'll go through some examples of the types of protocol steps and the types of data that we might collect, the types of evidence. The tool implements the authenticity model which the previous presentations have talked about, so I won't go into that. But what we wanted to do is to keep it simple to start with. As I say, it's a framework that can be built on to add capabilities through plugins. We are starting by capturing mostly textual information, but one will also be able to add attachments of various kinds. We have in mind a number of roles for users and a number of use cases. So initially we have a project administrator who, in the process of capturing information, evidence for authenticity, creates a project which will contain the information that's captured, or indeed he or she may import some existing provenance and evidence which will be appended to in the process of the chain of custody. Another important role, of course, is the person who captures the evidence. So we have in mind that that person would have to be authorized in some way to add evidence to the existing collection. So we'd have to register, you'd have to have a user profile, create various types of evidence, insert them into the collection of evidence that's being built up, and then would have to sign off. I'll come back to that in a moment. And the third role is that of a researcher, somebody or a consumer of the data, somebody who wants to examine this collection of evidence and make some sort of judgment about whether he or she really believes that this has sufficient authenticity to be usable. And we want to allow a variety of ways of browsing that evidence and of using it and exporting it to be used in other tools. One thing which we have we have inserted into the framework is what we call digests. So the issue that we wish to address here is that we have a great deal of flexibility in terms of the information that's captured, and the various authenticity protocols and authenticity steps. What we need is to be able to say that the evidence that's captured itself has not been tampered with. We need each step to be signed off by somebody to say, yes, I did check that number, or I did examine that aspect of the digital object. And so that person has to be able to sign, so we know that it wasn't just a fake entry. So what we use are cryptographic hashes at various times in the process, so that an information capturer can sign the fact that he or she has added information to the collection of evidence. And then at the end of the process, because that person might have included many steps, many authenticity steps, when he signs off his or her session, another hash is created which makes sure that we can check that that collection of evidence, which has now been extended, has not been tampered with. So we have a whole collection of hashes, so that at any time we can check that the collection of evidence has not been tampered with, and we can be sure that the person who has added the evidence is who we believe it to be. I'll give some examples of that later. We can use, of course, a variety of hash techniques. The important point about them is that essentially it takes the whole of the message of the whole of the collection of evidence, and it's then impractical to substitute that, given that hash. It's impractical to modify the message without it showing up when the hash is recomputed, and it's impractical for the information capturer to say that he or she has not inserted that evidence. Now, of course, one question arises as to where this hash should be kept. There are a number of projects which have been addressing this issue. The simplest way would be to take the hash that's been created from the latest collection of evidence and put that somewhere in a public place so that it cannot easily be tampered with. But the hash is also contained within the collection of evidence. And I'll show that in a moment. This is an example I'll come back to, but here we see that the user, the information capturer, has we have user 01. We would normally have an identifiable name. We have things like a timestamp. We specify the hash algorithm, in this case MD5, and the hash value. So that is contained within the evidence. So you see this as a piece of XML. This is the encoding we're using. We're not confined to that. And I think other aspects of that sample will become clear later. But a last point to mention is at any point in collecting the evidence, at any authenticity step, the capturer may want to express a degree of confidence that he has checked enough. So if you're looking at data, it'll be almost impossible to check every single value. Here we allow the user to say, well, confidence is 85%. Now that's clearly a judgment on the part of the person who's captured the evidence. We may be able to refine that in due course. We are developing an XML schema which to encode this information. This is based on the authenticity model that you've seen. It's only a portion of it because the various fields, the PDI fields down there will have a number of separate related schema. We have defined, or we are in the process of defining an XML schema to capture the information, the evidence that's being collected. You can see the structure here. It's based on the authenticity model, which was presented in the other presentations. An important point to note is that, as I mentioned at the beginning, we have to allow for the fact that there are many other sources and many other ways of capturing authenticity. For example, the premise model and its encodings. It's important that we are able to insert those other sorts of evidence into our container. This is very much a framework. It's extremely flexible. It's been designed that way, and we'll be testing it going through that process. And I'll go through one of the examples that we've been working through. I've tried to capture here something of the user experience, what the processes that a user will go through. First, of course, some sort of welcome screen. The user will have logged in, identified themselves, selected a project that is going to be worked on, in other words, something to which evidence is going to be added, selected the sort of things that are going to be done, and then starts to go through the different sorts of authenticity protocols and steps and parts of PDI that are going to be inserted. For example, the user will select that is going to use the ingest protocol, the source of data set step within that protocol, and in particular is going to select a particular type of PDI that's going to be added. In this case, the station location. Here, as was discussed in the authenticity model, there'll be some recommendations. These have been created by the author of the authenticity step and the authenticity protocol, and the user can then put in this case, it's just simple text. It could be cut and pasted from other sources of information, or indeed could be inserted as an attachment. And down at the bottom there, you'll see that the information capture is 85% confident that this is the source of the information that's being to which authenticity evidence is being attached. And then another user may be able to come along and look at all of this evidence, and here we will be inserting some sort of visual aid to give the researcher or the consumer of the data some visual clue as to how confident people were of the sorts of evidence that's been captured. And there'll be a variety of visualization plugins which will be available with the tool. So just to provide a little bit more detail, we want to be able to allow the design of authenticity protocols and authenticity steps. We need to, as part of that, a statement of policy, a recommendation will be inserted as the example on the slide. Secondly, in designing that protocol, a number of events can be added. And finally, the details of the protocols and the detail of the protocol and the individual steps will be inserted. This protocol can then be ingested into the tool and, of course, a variety of formats can be supported. And here's a brief example of that. Another example is something that may happen quite often, where data is transformed. So a recommendation that might be included in the protocol says, as you can see, for the received data file to be deemed of sufficient quality to support data analysis, it must have been successfully transformed into standard IWG. IIWG is a particular scientific data format. The use of the processing software must be included, and the steps are, for example, details of the transformation, the version of the software, the source, of course, the time and date, who is responsible, and the reason, just some text for saying why we believe that this software is reliable. For example, it might be in very common use throughout the community, and also the evidence about the transformation. So, have data values been checked between the original and the transformed value? How is it checked? All of that type of information can be captured in the tool.